So one of the mission statements Extreme has is to be the industry first cloud-driven end-to-end network vendor, or provide end-to-end network solutions managed through the cloud. And at some point we start talking about wired devices, and here we'll talk about the wired edge or the edge switches. We call it unified access layer because the same configuration principles, actually the same what we call network policies, are used to configure both wired and wireless devices. And the benefits that you get is obviously you get a single pane of glass type of deployment where you use the same workflows, use the same system to both monitor and configure both wired and wireless. In the case of ExtremeCloud IQ, it becomes the same platform to manage both wireless access, wired access, distribution, and core. So, and this is end-to-end. Also, manage branch routing, which we'll talk about a little bit later. It provides simplified configuration. So there's a single workflow. All you have to do is click what type of devices you want that network policy to configure. It's template-based. So you can configure, for example, port types on the switches across your whole campus or multiple locations, or even from a global deployment, again, from a single network policy. You can do it based on location, you can do it based on tagging, so it's very flexible in terms of deployment. You can manage stacks of switches or stacks of access switches through the cloud. And you also have the ability of remote management, so you can use the platform to remotely SSH or gain access to the console of the device to troubleshoot and maybe use it as a hop-off point to other parts of your network if that's something that you need during your troubleshooting session. So one of the problems, for example, if you're in a support organization, is how do I gain access to the customer's network so I can troubleshoot, so I can take the logs, see what's going on, maybe even replicate the problem. Well, the cloud takes that worry away because it's able to build a secure channel all the way down to your device. And as part of the support organization, you can use that device, you can be in that device without having to go through any hoops like getting VPN access or remote session for someone else's laptop. It's all there available for you to use. And finally, auto provisioning. So the same behavior that the platform provides for access points, not necessarily, I'm not going to say plug and play because plug and play is something you normally use in more of a consumer space. We call it auto provisioning or zero touch deployment. You plug in the switch finds the platform, auto provisions itself with the configuration, and away you go. So the same benefits apply to the wired side of the network. So let's take a look at the switch platforms that are natively supported by the ExtremeCloud IQ platform. So really you have 4 options. SR2208P. P stands there for PoE capabilities. It's an 8 gigabit Ethernet port, mainly developed for retail or small branches. It's a fanless device, so no annoying sounds coming from it. It provides PoE Plus or PoE up to 124 watts of power. It has 2 gigabit Ethernet uplinks, and the backplane allows for 20 gigabits per second switching. And then when we move to a more enterprise class, we are talking about the SR2224P, and then we have the 23 series, which is a 24P or 2348P. The difference between the 22 series and the 23 series is the 23 series is stackable, whereas the 22 series is not. And the 23 series has 10 gigabit Ethernet uplinks, whereas the 22 series only has 1 gigabit Ethernet uplinks. Both platforms provide PoE. The 2224P provides 180 watts of PoE power. You get 4 or up to 4 gigabit Ethernet SFP uplinks, and the backplane is capable of 56 gigabit per second switching. The 23 series, obviously more powerful, has 370 watts of power on the 24 port or 740 watts of power on the 48 port switch. They both have 4 10 gigabit SFP plus uplinks, and you either have 128 gigabits or 176 gigabits backplane capabilities, and all platforms have layer 2, layer 3. They have static routing capabilities and IPv6 capabilities, but they don't support dynamic routing. The main purpose of the switches is wired access. They're not designed, and the features exposed in the cloud are not really capable of doing anything in the upper layers, are like distribution and core. It's exclusively an edge or an access layer switch, and it has the security and switchboard configuration for those deployment scenarios. The next solution or next type of devices that ExtremeCloud IQ supports are branch routers. Actually, they're SD-WAN enabled branch routers. And the solution where you deploy edge Wi-Fi, edge switching, and branch routing is what we call a full stack, because you are deploying a full branch or a full remote location using Extreme devices managed by ExtremeCloud IQ. So we call that full stack. The branch routing in the solution includes unified configuration of Wi-Fi, switching, and routing policies. It's template based, just like the AP and switch configuration. It provides everything you need to set up a remote location, including a DHCP server, a DNS server. It can form VPN connections, or layer 3 VPN. It provides user-based and application-based routing policies. And on top of that, we have the SD-WAN component, which provides link state monitoring and multipath optimization, or a per packet multipath optimization. We'll take a look at how that works, but the main thing here is you use the same network policy to configure access points, switches, and branch routers, and that is the full stack. In terms of deploying the full stack, you have three types of devices to take into consideration. There's the XR200P, which is the entry-level branch router. We have the VGVA, or a VPN Gateway Virtual Appliance, which is the VPN concentrator you can deploy on top of a VMware hypervisor. And there's the XR600P, which is a more capable branch router that not only supports routing and SD-WAN, it can also act as a VPN concentrator as well, and it supports URL filtering. So let's take a look at the XR200P and XR600P devices themselves. So the XR200P has a 5-port gigabit Ethernet switch at the back. There's 2 PoE ports with up to 30.8 watts of power. There's a console port, a USB port, and in terms of performance, it can provide up to 200 megabits per second firewall throughput, and if you turn on the IPsec VPN, it provides up to 100 megabits per second of VPN throughput. So it's a small branch, a remote location type of device. However, the software does support SD-WAN and per packet multipath optimization and link state monitoring. The XR600P has 6 gigabit Ethernet ports, so it has a bigger switch at the back. You have 4 PoE ports with up to 60 watt of PoE budget, a console port, and 2 USB ports. The USB ports on both are mainly meant for 3G, 4G dongles, or if you have an LTE dongle, that's what you use to provide the mobile connectivity. And the XR600 can use to. The throughput or performance of the device is up to 600 megabits per second of firewall throughput and up to 250 megabits per second when you turn on the IPsec VPN. And just like the XR200P, the XR600 does provide SD-WAN with multipath optimization and link state monitoring as well. And like I mentioned before, it can also act as a VPN concentrator, whereas the XR200P cannot. Next is the VGVA. So when you're deploying full stack, you decide whether you want to terminate your VPN tunnels on the XR600P or you want to terminate it on a virtual VPN gateway or a VPN Gateway Virtual Appliance, or in short, VGVA. The VGVA is designed to terminate two types of tunnels, either GRE in a local scenario or in a remote scenario, IPsec VPN. When you're deploying it for a GRE tunneling, usually the deployment scenario is you want to use cloud APs, but you don't want to use the distributed data plane. You want your data plane for at least some of your users or for some of your Wi-Fi networks to be centralized. For example, in a financial institution type of environment, you need to tunnel your guest networks to a DMZ. And from there, that guest traffic needs to go to a separate internet uplink. You can implement that using VGVA and cloud APs and leverage GRE tunnels to tunnel all that data or that client data back to a central point, which is the VGVA. More commonly, the VGVA will be used to terminate remote VPN connections coming from remote locations, either branches or remote workers or teleworkers. The VGVA is available as an OVA image and runs on top of the VMware hypervisors. It supports up to 1,000 VPN tunnels, and it also supports routing like OSPF and RIP version 2. So it can peer with your local router, your core router, to exchange the other routes to the network. And that will provide interconnectivity between your VPN solution, your branches, your SD-WAN, and your corporate network. When deploying a corporate VPN scenario, ExtremeCloud IQ provides a cookie cutter template for you to be able to quickly and easily deploy and manage the VPN deployment. That means IP address management. You no longer need Excel spreadsheets or a central database of which subnets have gone where, what's used where. It's all done in ExtremeCloud IQ and configured for you. So let's look at an example. So when you deploy a corporate VPN scenario, you're going to have a VGVA at a central location or your headquarters, and you're going to have multiple branches running XR or XR200 or XR600P branch routers. All of these devices will be managed through ExtremeCloud IQ. So they will have connectivity to the ExtremeCloud IQ platform, where they will receive their configuration and also where they will send their monitoring data to. Once the routers and the VGVAs are configured, the routers will build a VPN to one or two VPN gateways for redundancy. And then the routes will be configured through that connection and synchronized between the VPN gateway and the branch router using a TCP-based route exchange mechanism. And the VGVA itself will then run OSPF or RIP version 2 with your local corporate router to exchange other routes that you have on your corporate network as well, providing end-to-end connectivity between your VPN, your WAN, and your local network. The subnetting will be done automatically for you. Guest network access will be done automatically for you, and you'll be able to configure which traffic goes into the VPN tunnel, which traffic breaks out locally, and which traffic needs to be routed based on either who the user is or based on what application you're using. So you have user-based and application-based routing capabilities in the VPN solution as well.